Section 5.1 is on page 312, talks about antiderivatives and indefinite intervals. Now chapter 5 altogether uses antiderivatives, or specifically integration, to solve problems. So if I told you that y equals x squared plus 3, and if I want to take a derivative of that, that would be 2x. An antiderivative is pretty much going backwards. Given 2x, you want to figure out what did you take a derivative of to get 2x. But if you look at x squared minus 500, if I take a derivative of that, that is also 2x. And if I take a derivative of x squared plus 15,000, the derivative of that would be 2x. So if I want to go back, suppose I told you, hey, y prime is 2x. What did you take a derivative of to get that? Well, from the problem I did, you already know there's an x squared in there. So again, you're going backwards. You would know that there is an x squared in each of those, but you can't figure out whether it was the x squared plus 3, x squared minus 5,000, x squared plus 15,000, or just x squared. Because if I had y equal x squared, the derivative of that would be 2x as well. So what you do, you add a constant. You say, well, look, there could have been a number, there could not have been a number. Let me take a derivative of one more function. If I was looking at y equal x squared, you would notice that y prime is also 2x. So you would say, if it is this case, it's a plus 0, c equals 0. If it's this case, we're talking about 15,000. If it's this case, we're talking about negative 500. And if it's this case, we're talking about 3. So here's the definition. It says, a function capital F of x is an antiderivative of a function f of x. So here they're labeling this f and this capital F. This is f, this is capital F. This is f, this is capital F. And this is f, this is capital F. And here, if you call this little f, here they're saying this is the antiderivative of this. Meaning, if you take a derivative of this, you should get that. So, an antiderivative, capital F is the antiderivative of this lowercase f, is if I take a derivative of this, and I'll get that. So whenever I get the answer, if I take a derivative of my answer, I should get back what I started with. If I ask, what did you take a derivative of to get 2x? If you say x squared plus 3, if I take a derivative of that, I should get the 2x. Now we're going to start with the most basic rule, and this is the term that comes up a lot more than others. If I'm trying to figure out what an antiderivative is, an antiderivative is going to be denoted by this symbol, which is an integral. And when you integrate, that's called integration. An integral of a power function, a variable raised to a number. As long as that number is not negative 1, you're reversing the derivative. If you recall, the derivative of x to the n was bring the power down, subtract 1 from the power. To undo that, if you want to go backwards, you would add 1 to the power to undo the subtraction. And do you notice when you put it right there, you're actually multiplying? To undo multiplication, you divide. So, very simple. We start off on page, and let me see what page is that on. Page 391. So if I start off on page 391, I'm looking at problem number 2, and it says, what do you take a derivative of to get 5x to the 4th? And as you notice, they add 1 to the power, which is x to the 5th, and they divide by it. So here you don't have to do much. They're giving you the problem and the answer. They're saying verify that this statement is true by showing that the derivative of the right side equal to the integrand. Integrand is this part. If I take a derivative of this, wouldn't you bring the power down, subtract 1 from the power, and that would be a 0? Wouldn't that be 5x to the 4th, which is literally what I have in there? Here, they say, well, show that this is the antiderivative of this, meaning if I write this as x minus 3x to the 1/3 plus c, and if I call this capital F of x, if I take a derivative of that, wouldn't that be 1 minus, bring the power down, subtract 1 from the power, plus 0? Wouldn't that be 1 minus 1 over, isn't that the cube root of x squared? And isn't that lower f of x, which is this? So only the first couple of problems, they give you the problem and the answer. The rest of the chapter, you're going to find this on your own. So here they're saying, find the indefinite interval. That's another way for saying, find what did you take a derivative of to get 2x. Well, the numbers we ignored, just like we ignored with derivatives. I want to take a derivative. I want to figure out what did I take a derivative of to get x to the 1. Well, add 1 to the power and divide by that. Don't forget the plus c. Those cancel out. X squared plus c. That's what you take a derivative of to get this. On number 16, the same deal. You ignore the 8 and you say add 1 to the power. That's y to the negative 4. Divide by that. Plus c. So those cancel out. You would take a derivative of negative 2 y to the negative 4 plus c. That will give you 8 y to the 5th. And here the same deal, you would ignore the 3 and you would say add 1 to the power, divide by that, plus c. So that is 3/5 t to the 5th plus c. That's what you take a derivative of to get 3x to the 4th. Now, we want to rewrite functions to match x to the n, so that when we integrate, we know we add 1 to the power and divide by that. And don't forget the plus c. As long as n doesn't equal negative 1, and that doesn't happen in this section. So if I'm looking at this, wouldn't you say this is the integral of x to the negative 4 dx? Wouldn't you add 1 to the power and you divide by that? And if you simplify, isn't that negative 1 over 3x cubed plus c? That would be what I take a derivative of to get this. Any given time, you could go on the side and take a derivative of this, and it should give you that part. So you could always check your answers. If I'm looking at this problem, I'll notice that this problem is really x. Isn't that x to the 3/4? So a power function appears in a lot of problems that we have. Isn't that the integral of x? 1 plus 3/4 is 7/4. Well, integrate. Add 1 to the power. 7 over 4 plus 1. Excuse me. 11 over 4. And divide by that. So wouldn't that be 4x to the 11 over 4 divided by 11 plus c? Because whenever you have 1 over a fraction, you multiply by the reciprocal of the fraction. So something that we're going to be doing and dealing with for a while. And here are the rules. The rules are close to differentiation, taking a derivative. If you take a derivative of if you take an integral of a constant, what do you take a derivative of to get a constant? It's really the constant times x plus c. think of it as the integral of k times x to the 0. Don't you add 1 to the power and you divide by that plus c, and there it is, assuming that this k is a constant. If you've taken a derivative of k times a function, just like we did with derivatives, if you find an antiderivative, ignore the k and integrate the function that depends on x. If you have two functions added, find the antiderivative of the first, find the antiderivative of the second, and add the result. Similarly with subtraction, just like we did with derivatives. Now, if we pick the next set of problems and we apply these rules to them, just like you were taking a derivative, wouldn't you take a derivative of x to the second and 7 independently? Here you would say, well, add 1 to the power, divide by that, and if there's a 7, that means it must have been a 7x plus c. And if you look at number 32, that would be the 2 you ignore, add 1 to the power, divide by that, the 9 you ignore, add 1 to the power, divide by that, and the 8 must have been an 8x plus c, and you need to simplify that a bit. 3 divides 9 3 times, and on any problem, if you take a derivative of the final answer, you should get this. And if I look at the last problem, I need to manipulate it just a bit. So I would say, algebraically, this is the integral of t squared over t squared plus 2 over t squared dt. That is the integral of 1 plus 2. If you move this up, isn't that t to the negative 2 dt? And that would be t plus 2, add 1 to the power, divide by that plus c. So the answer will be t minus 2 over t plus c. That's what you take a derivative of to get this. And we need a lot of practice on those. Now, to find c, they must give us a point on the graph or that satisfy the function, and here it is. It says, find the particular solution that satisfies the differential equation with the initial condition. A lot of fancy terms. We're just gonna figure out that f of x, if you have a derivative, f of x is the integral of 9x squared with respect to x. F of x is actually 9, add 1 to the power, divide by that plus c. F of x is 3x cubed plus c. I would have been done here if they would not have given me this case. This is saying if you throw a 0 in for x, then the y would be a negative 1. That would mean c equal negative 1. All what you have to do is go back here and say, well, look, the antiderivative that satisfies this condition is really 3x cubed minus 1. And you could tell, if you put a 0 in for x, you will get a negative 1, and if you take a derivative, you'll get 9x squared. So giving you a point on the graph, or a point that satisfies this equation, allows you to find c. Here I'm going to say f prime of x is x to the 1/2 plus 2x. And if I want to find f of x, I would integrate x to the 1/2 plus 2x with respect to x. And my original function must have been x, add 1 to the power. If you divide by 3/2, instead of dividing by a fraction, you multiply by the reciprocal. The 2 you ignore, add 1 to the power, divide by that, plus c. So f of x, the general solution, is 2 over 3, the square root of x cubed, plus x squared plus c. That would have been my final answer if they would not have given me this point. They're saying if x equal 4, that is 2/3 times the square root of 4 cubed plus 4 squared plus c, and that should equal the y. What should that equal? That should equal a 25 over here. This should be a 25 2/3 square root of 2, square root of 4 is 2, cubed, that's an 8. So if I clear the fractions, 75 plus 75 equals 16 plus times 3, that's 48, plus 3c. 75 will equal 64 plus 3c. If you subtract 64 from both sides, that will be 11 equal 3c. So that means c is 11 over 3. All what you have to do is come back and put it right there and say the final answer for this problem is 2/3 the square root of x cubed plus x squared plus 11 over 3. That would be my final answer. If they gave me a point on the graph, they call this an initial value problem, meaning they gave you initial value. Then you find that c and everybody's happy. Now, let's apply this to what we know. And here we are. If I would take finding the cost function, find the cost function for the given marginal cost and fixed cost. Well, if this is a derivative, which is the marginal cost, the cost would be the integral of 1 over 50x plus 10 with respect to x. So the cost function would be the 1 over 50 you ignore, add 1 to the power, divide by that, plus 10x plus c. So the cost function is actually 1 over 100, or x squared over 100, plus 10x plus c. Now, the fact that they told me the fixed cost is 1,000, that means when you have 0 units, the fixed cost is always 1,000. I will say c of 0 is 0 squared over 100 plus 10 times 0 plus c, and that should equal 1,000. Well, that's 0 plus 0 plus c equal 1,000, which means c is 1,000. So my cost function would become x squared over 100 plus 10x, and instead of that constant, you know what? Since there are too many c's, I'm going to call that, the book calls it k, let's call it k. It's easier that way, so you don't mix the constant with the cost function. And that would be my final answer. So the fixed cost you pay initially before you produce any units. That's kind of like the rent or the utilities or the machinery. Same deal with revenue. If I have the marginal revenue, the way you would really do it, you would cross multiply. You really don't have to show that, but that's really what you do. And then you say, you know what? That's revenue. You could skip this part and jump to the straight. The revenue will be the integral of 310 minus 4x with respect to x. So the revenue is 310x minus 4, add 1 to the power, divide by that plus c. The revenue function is 310x minus 2x squared plus, I'm so stuck on c, sorry guys, I'm going to call this k in these applications, so you don't mix c with cost. Now they did tell me when you have sold no units, you have no revenue. which means if I throw 0 in there, that's 310 times 0 minus 2 times 0 squared plus k, and that should equal a 0. Well, this is 0, this is 0, that means k equals 0. So my final answer for the revenue function of x units is 310x minus 2x squared. You could write plus 0 if you wish, but we normally don't just say plus 0 because that doesn't change a value. And a couple more to go. If they gave me, if I wanted to figure out what the profit is, given the marginal profit, well, I could say the profit is the integral of negative 40x plus 250, the variable plus the fixed with respect to x. The actual profit will be negative 40x, add 1 to the power, divide by that. A constant, that means you must have had 250x plus k. The profit function is negative 20x squared plus 250x plus k. All what I have to do is find that k, and here they're saying when you sell 5 units, the revenue is $650. So if I throw in 5 units, that's negative 20 times 5 squared plus 250 times 5 plus k, and that's 650. Solve for k and you're done. So in this case, I'm looking at 25. You could do that in a calculator. There's no need for you to do that by hand. I like to do it by hand, but I want to save time. If I take negative 20 times 5 squared plus 250 times 5, I'll get 750. So 750 plus k equals 650. That means k must be a negative 100. So the profit function of x units is negative 20x squared. I'm copying this down. Plus 250x instead of k minus 100. And that would be my final answer. And I wanted to do one more just to make sure we see it. If this is the marginal profit, then the profit is the integral of negative 30x plus 920 with respect to x. The profit is negative 30, add 1 to the power, divide by that. If you have a constant, it must have been the constant times x. Find k and you're done. And again, we would take, when you sell 8 units, you will get 6,500. That is, by the way, I forgot to clean that up. That's negative 15 times 8 squared plus 920 times 8 plus k, and that should equal 6,500. Again, I'll use my calculator, and in this case, I'll be taking negative 15 times 8 squared plus 920 times 8. That would be negative 8,320 plus k equals 6,500. If I move that to the other side, k will be, if you add those, 0, 2, 8, 14. So my profit function is actually negative 15x squared plus 920x, and instead of k, $14,820. And the homework is listed right there. And that concludes this section.